Welcome to ASCII Character Encoding. Computers work using zeros and ones, but we communicate using letters, numbers, and symbols. So, how does a computer understand these characters? This is where ASCII comes in. ASCII gives each character a standard numerical code. That number can then be converted into binary. This allows computers to store, process, and exchange text. In this lesson, we will learn how ASCII works. ASCII stands for American Standard Code for Information Interchange. ASCII gives each character a unique numerical code. For example, the uppercase letter A has the decimal ASCII value, 65. That value can then be represented in binary as 01000001. So the process is simple: character to decimal code to binary. This is how computers can represent and store text. Computers need an agreed standard to represent text. Imagine one computer uses 65 for the letter A, but another computer uses 88 for the letter A. When they exchange information, the data could be interpreted incorrectly. ASCII solves this problem by giving computers the same standard codes for characters. This allows text to be exchanged correctly between different computer systems. Let's look at how a character becomes binary. We start with the letter A in ASCII. The letter A has the decimal code 65. Next, 65 is represented in binary as 01000001. This binary pattern can then be stored in computer memory. So remember, character, decimal code, binary, memory. The original ASCII standard uses 7 bits. Each bit can have one of two values, 0 or 1. Here, we can see a 7-bit binary pattern. Because there are 7 bits, ASCII can create many different combinations. These combinations are used to represent different characters. So remember, original ASCII uses 7 bits. Let's see why 7 bits give us 128 possible codes. With 1 bit, we have 2 possibilities, 0 and 1. With 2 bits, we have 4 possibilities. With 3 bits, we have 8. As we add more bits, the number of combinations keeps doubling. So with 7 bits, we calculate 2 to the power of 7, and that equals 128. This means ASCII can represent 128 different codes. ASCII can represent different types of characters. These include uppercase letters, like A, B, and C, lowercase letters, like A, B, and century. It also represents number characters, such as 1, 2, and 3. ASCII also includes punctuation and special symbols, like the @ sign, hash, %, and ampersand. And some ASCII codes are used for control actions. So ASCII provides standard codes for many different characters, used by computers. These are called printable ASCII characters. Printable characters are symbols that we can normally see on the screen. They include uppercase letters, A to Z, lowercase letters, A to Z. They also include digits, 0 to 9. And ASCII includes many punctuation marks and special symbols. For example, the exclamation mark, hash, %, and question mark. These characters can all be represented using their own ASCII codes. Not every ASCII code displays a visible character. Some ASCII codes are used for control actions. For example, backspace removes a character. Carriage return moves the cursor back to the beginning of the line. And other control codes can change how text is handled. These codes may not display anything on the screen, but they still tell the computer what action to perform. So remember, ASCII represents both visible characters and control actions. ASCII codes are arranged into useful groups. The digit characters, 0 to 9, use decimal codes. 48 to 57, uppercase letters. A to Z, use codes. 65 to 90. And lowercase letters, A to Z, use codes. 97 to 122. Notice that characters in each group have consecutive ASCII codes. These patterns make ASCII easier to understand and useful when programming.